So, the next concept in this chapter is simple pendulum. So, what do you mean by this simple pendulum? Already explained in the beginning. Simply you have to take a metal sphere. That metal sphere is called as a bob, B-O-B, and that metal sphere, it is suspended from a rigid support with the help of a string or a thread. Generally in practically we will be connecting a thread. Okay. So, here this is the metal sphere suspended from a rigid support with the help of a thread, that is simply called as a simple pendulum. Now, here if at all the simple pendulum is obeying some conditions, then we will be calling it as ideal simple pendulum. Ideal simple pendulum means we cannot reach that conditions practically, but if at all we are reaching that conditions practically, then that is called as ideal simple pendulum. Ideal simple pendulum. What are the conditions to be obeyed? If you are observing that, first here the bob should satisfy two conditions. First condition is that the bob should be of point size, that means the sphere should be of point size, and second condition is that the sphere should be of heavy mass. So, whatever the sphere you are using or whatever the bob you are using, it should satisfy two conditions. One, it should have point size, and one more is that it should be having heavy mass. And next, coming to the thread. The thread should satisfy three conditions. First condition is that the length of the thread should not be increasing as that of rubber band. The length of the thread should be constant. So, that type of thread is called as inextensible thread. Moreover, the thread should be flexible. It can be twisted, it must be in such a way that it must be twisted easily. That is also called as torsionless. And next condition is that whatever the thread we are taking, it should be massless thread. So, thread should satisfy three conditions. First one is it should be flexible, second one it should be massless, and third one it is inextensible. Now, if you are inserting these conditions in the definition of simple pendulum, that becomes ideal simple pendulum. So, coming to the definition of ideal simple pendulum, a point size and heavy mass sphere suspended from a rigid support with the help of inextensible, flexible and massless string or thread is called as ideal simple pendulum. If you are inserting these conditions, that becomes ideal simple pendulum. Remember, ideal simple pendulum is only an imaginary case, we can't reach that. Otherwise, it is simply called as practical simple pendulum. Clear? Now, we have to obtain the equation for time period of a simple pendulum. What do you mean by this? Time period of a simple pendulum. So, in order to understand the time period of a simple pendulum, here, just observe this animation. So, in this animation, this bob is going from left side to the right side, and again from right side to, it goes up to the same point. It is starting from left side to right side, and again it is going up to the same point. That means we say that it has completed how many oscillations? One oscillation. From starting point it has to go to this side, and again it should return back. Then we say that the simple pendulum has completed how many oscillations? One oscillation. From starting point it has to go to this side, and again it should return back. Then we say that the simple pendulum has completed how many oscillations? One oscillation. So, for completing this one oscillation, it takes some time. That time is simply called as time period. What is it called? Time period. So, time taken to complete how many oscillations? One oscillation. That is simply called as which period? Which period? Time period. Okay, so now we have to obtain the equation for time period. Right, we have to obtain the equation for time period of the simple pendulum. In order to obtain the equation for time period of a simple pendulum, consider this diagram. In this diagram, here this point O, wherever the cursor I am placing here, this is called point of suspension, wherever we are hanging the thread. And the center of this sphere here, wherever the black dot is there here, that center of this sphere is called center of oscillation. Center of oscillation. Once again, point O is called
center of oscillation.
Point O here, wherever the cursor is there, point of suspension. What is it called? Point of suspension. And here point A is called center of oscillation. Center of oscillation. The distance from this point of suspension to the center of oscillation, that is called length of the simple pendulum. That is called length of simple pendulum. Is it clear? Distance from which point to which point? You have to respond.
Point of suspension to center of
Oscillation. Point of suspension to center of oscillation, that is called length of simple pendulum. Is it clear? We should measure only up to the center of the sphere. We should not measure up to the bottom of the sphere. Okay. Now, whenever the simple pendulum is in the rest position, this is called equilibrium position, or you can call it as mean position. When the simple pendulum is in rest position, it is called which one? Mean position. Now, in the mean position, what happens? The gravitational force will be pulling this simple pendulum in the downward direction. That is simply nothing but gravitational force here. This is nothing but F equal to mg. At the same time, there will be some force created in the thread in the upward direction. This is called tension. What is it called? Tension. So, this tension and this gravitational force, they are exactly equal and opposite. So, they will be cancelling each other. That is why this simple pendulum is in which position? Mean position, or it is in the rest position. It is not moving. Now, what we are doing? We are taking this simple pendulum from mean position to right side up to here, up to point B we are taking. When you are taking up to point B, again there is some force acting in the thread towards the point of suspension, that is called tension, and the gravitational force will be exactly acting in the downward direction again. Remember, this line and this line will be parallel to each other, this pink color and red color. Here if you are observing, this gravitational force and this tension, are they exactly opposite? No, they are in different directions. So, for that what we do, we will try to divide this gravitational force into two parts. One is mg sin theta and one more is mg cos theta here. Mg sin theta and mg cos theta. As we have divided in path of projectile parabola, we have divided u cos theta and u sin theta. In the same way, this side it is mg sin theta and this side it becomes mg cos theta. Now, what is exactly opposite to tension? Mg cos theta. These two will be equal and they are opposite. So, these two will cancel each other. What is the extra force remaining now? Mg sin theta is remaining. Okay, so what does this mg sin theta do means? This mg sin theta will try to bring the simple pendulum again to which position? Mean position. Because the simple pendulum cannot stay at point B permanently. Again it want to come to the mean position. So, this force is trying to bring the simple pendulum towards which position? Mean position. But what we have done, we have taken the simple pendulum from A to B. For how much displacement? X. So, displacement is in right side direction or left side? Right side. But this mg sin theta is acting right side or left side?
Left side.
Left side. So this mg sin theta is in opposite direction to which one?
Displacement.
Displacement. This mg sin theta is called as restoring force. Remember, mg sin theta is called which force?
Restoring force.
Because it is trying to restore the position of the simple pendulum to point A. It wants to bring it back to the point A. So mg sin theta is called restoring force, and this restoring force is in opposite direction to the displacement. So with respect to that, we are writing one equation here. That equation is nothing but F is equal to mg sin theta. Is it visible?
Yes, sir.
Yes, sir.
So this is called as mg sin theta. That is nothing but the restoring force. This one, F equal to mg sin theta, or we are taking minus sign because it is in opposite direction to the displacement. Restoring force. Okay. Now according to Newton's second law, this F can be written as what? Mass into acceleration. Okay. So instead of F, we are substituting it as F equal to m into A. Now if you are substituting that, we can write it as ma is equal to what? Minus mg into sin theta. So anything cancellation?
M will be cancelled.
M will be cancelled. So here m will be cancelled. What is left over? A equal to minus g into sin theta. Take it as first equation. Now in this also, if at all this theta value is very, very less. What do you mean by this theta value very, very less? Observe the diagram. In this is the angle theta somewhere here, wherever the cursor is there. Okay, this theta value should be very, very less. Okay, if you are taking it for more, in this one, if you are taking the simple pendulum up to here, for example, in this way, if you are taking up to here, in this case, the angle will be more. Whenever the angle is more, what happens? The distance and displacement will not be equal. Distance and displacement means what here? For example, here I am drawing. We are taking the simple pendulum in this way up to here. This is in the curved path. But if you are taking the displacement, displacement is nothing but the shortest distance between the initial point and the final point. This will be in this way. So if you are taking it for more distance, what happens? The distance and displacement will not be same. So for that reason, in the simple pendulum, the angle should be very less. Then we can approximate the distance and displacement should be less. So we are always assuming theta is very, very less. So if theta is very, very less, the sin theta value can be always written as only theta. This is approximation. If theta is very, very less, remember sin theta can be written as what only? Theta.
Theta.
Now substitute this theta in this equation. What happens to the first equation now?
Equal to minus g theta.
Instead of just sin theta, we are writing it as theta. Then it becomes what? A is equal to minus g into
Minus g
theta.
into theta.
Now take it as second equation. Remember this equation. Now in geometry, mathematics, one more condition. This in first sem also I have taught you. Length of the arc is nothing but angle into radius or radius into angle. What do you mean by this length of arc and what is radius here in this diagram? Once again we will go for this diagram here. Hold it vertically so that you can observe the total diagram. So here we are suspending from point A, from point O to point A. This is the length of the string, that is L, and starting from point A, if I am just rotating the simple pendulum in this way, we are going here, totally we are coming in this way, and again if you are coming back side, you will get a one circle. What will be the radius of that circle?
R.
Here R is not there. What is the radius of that circle? L will be the radius of the circle. Okay, L will be the radius of the circle, and if you are taking this arc in the sense from point A to point B, the value of arc is how much?
L.
Here from A to B, how much displacement? This is nothing but arc. Arc means here this portion of curved part. This is nothing but arc. Arc value is how much? X.
X.
And what is the theta we are having? Only theta. So what is the relation we have written? Length of arc is equal to radius into angle. Okay, what is the length of arc here? X. What is the radius?
L.
What is angle?
Theta.
Theta. So how can you write the equation now? Here. Length of arc is equal to radius into angle. So we are writing it as x is equal to L into theta. So from this equation theta is equal to what?
X by L.
X by L. We are taking it as third equation. Now substitute this theta value in the previous equation. Whatever you got here, A is equal to minus g theta we got. If I am substituting in that, this equation becomes A is equal to, able to understand, this theta value, this theta value we are substituting here. Then that becomes what here? A is equal to minus g into x by L. Now just modifying this, A is equal to minus g by L, x we are writing outside here. So A is equal to minus g by L into x. This is the equation we are getting now. But in the yesterday's class, already we got one more equation. What is the equation we got here? A equal to minus omega square y. This was the equation we got in yesterday's class. So this equation is representing which motion? Simple harmonic motion. Now observe this equation and this equation. Both are similar or different? This blue color part and green color part. Similar or different?
Similar.
Acceleration is there, acceleration is there, minus sign is there, minus sign is there. Here x is the displacement and here y is the displacement. So both are similar. That means in place of omega square, what is there?
G by L.
G by L. So that we are writing here. That means in place of omega square, we are having G by L. Clear? So omega can be written as what?
Under root of G by L.
Under root of G by L. Now we got omega value. Now our intention is to calculate the time period. Right, in the first semester, in rotatory motion, in circular motion, I have given you the formula for time period. What is the formula for time period? Time period formula. Forgot. Good. Once again we'll go for the time period. Here I have said that this is the simple pendulum. We are starting from here at point A. We are going in the form of a circle in this way and we are coming this side again. Okay, so when you are completing one circle, we are rotating for how much angle? 360 degrees. 360 degrees means how many radians? Radians. ఇక్కడ నుంచి ఇక్కడ వరకు వచ్చినాం అనుకోండి 90 degrees కదా. 90 degrees ని it is called as pi by 2. If you are going up to here, one more pi by 2. If you are going up to here, one more pi by 2. If you are coming up to here, one more pi by 2. So 4 90 degrees are there, 4 pi by 2s are there. So 4 by 2 pi. So 360 degrees is nothing but equal to how many radians? 2 pi radians. Okay, so we are rotating for 2 pi radians. Okay, so for that we require some time, and this is moving with some velocity also. In circular motion, the velocity we are calling it as angular velocity. Which velocity? Angular velocity. So time period is nothing but angular displacement by angular velocity. Time period is nothing but angular displacement by angular velocity. In this case, what is the angular displacement? 2 pi. Angular velocity is how much? Omega. Omega means small w. So that formula we have to take here. Now coming to our formula here. Up to here we have completed. Omega is equal to under root of g by L. So time period formula is this one, 2 pi by omega, that is angular displacement by angular velocity. Now substitute this omega value in this equation. If I am substituting, what happens? T is equal to 2 pi by under root of g by L. Is it okay?
Yes, sir.
Now take this g by L to numerator. If I take it to numerator, what happens? T is equal to 2 pi under root of L by g. So this is the formula for time period of a simple pendulum. T is equal to 2 pi under root of L by g. So this is one method of deriving by taking linear variables. If you want, you can derive this in one more way also, that is by angular variables, because you are not perfect with that circular motion. I have taken only the linear variables. Same derivation you can have in one more way also. Okay, so remember, in this 2 pi is constant, L is the length of simple pendulum, g is acceleration due to gravity, and t indicates time period. Time period means time taken to complete one oscillation. Now in some of the simple pendulums, what happens? The time taken to complete the one oscillation, it is nothing but equal to only 2 seconds. In this diagram, once again observe, we are going from we are starting from here, from the left side point, we are going to right side. For example, it is taking 1 second time to right side, and now starting from right side to go to the left side, that is to the starting point, again it takes 1 second time. So the total time taken to complete one oscillation, that is nothing but 2 seconds. So the time period of simple pendulum is 2 seconds. So going to right side 1 second, coming to left side 1 second. How much time it has taken?
2 seconds.
So for completing one oscillation, it has taken 2 seconds. So this type of simple pendulum whose time period is 2 seconds, that is called seconds pendulum. If the time period of any simple pendulum is 2 seconds, then it is called which pendulum? Seconds pendulum. In olden days you used to have the pendulum clocks. ఇప్పుడు కూడా కొన్ని ఇళ్లలో మీకు కనిపిస్తూ ఉంటాయి. పెండులం క్లాక్స్ అంటే క్లాక్ పైన ఉంటుంది హ్యాండ్స్, కింద ఒక స్టీల్ కలర్ బాబ్ మూవ్ అవుతూ ఉంటుంది. That are called pendulum clocks. So in that pendulum clocks, the time period will be 2 seconds. That is called seconds pendulum. So the definition is important. If time period of a simple pendulum is 2 seconds, then it is simply called as which pendulum? Seconds pendulum. Clear? Now here, if you are observing this equation, in this equation, the time period only depends on what and what? The equation Jarat, because 2 pi is constant, time period only depends on what? Length and acceleration due to gravity. How is the time period depending on length? Directly or inversely? Directly. How is the time period depending on g? Inversely. So time period is directly proportional to square root of L to 1 by under root of g. Okay, because 2 pi is constant. ఇది కాన్స్టెంట్ తీసుకున్నాం అనుకోండి, ఫస్ట్ ఈ రెండు కాన్స్టెంట్ తీసుకోండి. 2 pi and g కాన్స్టెంట్ తీసుకున్నాం అనుకోండి, ఈక్వేషన్ ఏం రాయొచ్చు? t ప్రపోర్షనల్ టు రూట్ L. If at all 2 pi and L are constant, t proportional to 1 by root g. So time period is only depending on length of the simple pendulum and acceleration due to gravity. Now is there any mass here in this equation? No. That means time period of a simple pendulum does not depend on mass. Is there any shape in this equation? Any shape? No. Time period does not depend on shape. Is there any material in this equation? No. So time period does not depend on material also. What do you mean by material, shape and size? Once we'll go for the diagram once again. So observe the diagram here. In this diagram, we have taken the sphere here, spherical shape. If you want, you can take the cylindrical shape. This metal, whatever you are taking, we can take cylindrical shape, or you can take conical shape, or you can take cube shape. Whatever may be the shape of the bob we are taking, the time period will not change, because time period does not depend on the shape of the material. And even if you are preparing this sphere with iron or copper or gold or silver, whatever the material you are changing also, the time period will not change. Okay? And moreover, if you are taking this as 10 grams, 20 grams or 1 kg also, the time period will not change. That means time period does not depend on mass, size, shape and material. What do you mean by size? The small sphere you can take it as big sphere also. Then also the time taken to complete one oscillation will not change. So time period does not depend on mass, size, shape and material. Second is, time period only depends on square root of length of the simple pendulum. Time period is inversely proportional to square root of acceleration due to gravity. These 3 points are called as laws of simple pendulum, LAWS, laws of simple pendulum. Test from the equation you will be getting. Now one simple question. When you are going to a park, you are having the swing. In the swing, one person of 50 kg, he is sitting in the swing and he is swinging. Now the time period is example some 5 seconds. To make one oscillation, 5 seconds. In the same swing, another person of mass 60 kg is sitting. 2 persons are now swinging. What happens to the time period?
Same.
Time period will be same or different?
5 seconds.
Same, different or same? ఇప్పుడే చెప్పాము అందుకనే టైం పీరియడ్ డస్ నాట్ డిపెండ్ ఆన్ వాట్? టైం పీరియడ్ డస్ నాట్ డిపెండ్ ఆన్ మాస్. మనం ఇక్కడ మాస్ గురించి చెప్తున్నాం ఇప్పుడు. ఫస్ట్ 50 kg పర్సన్, నెక్స్ట్ 60 kg పర్సన్. మాస్ ఈజ్ ఇంక్రీజింగ్ బట్ టైం పీరియడ్ విల్ నాట్ change. So time period does not depend on the mass. In that way some reasoning questions will be asked. Okay. So if at all length of the simple pendulum increases, what happens to the time period? Increase or decrease? Changes. Increase or decrease? Increases. We have said that directly proportional. If at all we are taking the simple pendulum onto the moon, if we are taking simple pendulum onto the moon, the time period increase or decrease? What happens to the time period? Inversely proportional అని చెప్పాం కదా. టైం పీరియడ్ మూన్ 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 పైన జీ వాల్యూ తక్కువనా ఎక్కువనా? అండ్ ద మూన్ జీ వాల్యూ ఈజ్ లెస్ ఆ మోరా? మరి జీ వాల్యూ లెస్ అయితే టైం పీరియడ్ ఏం కావాలి? ఇన్వర్స్లీ అని చెప్పాం కదా. జీ తక్కువ ఉంటే టైం పీరియడ్ ఇంక్రీజ్, జీ వాల్యూ ఎక్కువ ఉంది అనుకోండి టైం పీరియడ్ ఏమైంది? డిక్రీజ్. అందుకని ఇన్వర్స్లీ చూసుకోవాలి ఫస్ట్. ఆల్వేస్ అది జీ డినామినేటర్లో రాస్తాం కదా, ఇంక్రీజ్ అంటే కుదరదు. మూన్ పైన జీ వాల్యూ తక్కువ ఉంటుంది కాబట్టి టైం పీరియడ్ ఏమైంది? ఇంక్రీజ్ అవుతుంది. ఎన్ని టైమ్స్ ఉంటుంది మూన్ పైన జీ వాల్యూ? G/6 అంటే అర్త్ పైన ఎంత ఉంటుందో దానికంటే 6 times తక్కువ ఉంటుంది, అంటే 9.8/6. ఒక్కొక్క ప్లానెట్కి ఒక్కొక్క వాల్యూ ఆఫ్ G ఉంటుంది. యాక్సలరేషన్ డ్యూ టు గ్రావిటీ విల్ బి చేంజింగ్ ఫర్ డిఫరెంట్ astronomical bodies. Okay, now for today last question. According to this equation, if you are taking the simple pendulum to center of earth, మనం ఒక సింపుల్ పెండులంని సెంటర్ ఆఫ్ ఎర్త్కి తీసుకెళ్ళాం. సెంటర్ ఆఫ్ ఎర్త్కి తీసుకెళ్తే వాట్ హ్యాపెన్స్ టు ద టైం పీరియడ్? సెంటర్ ఆఫ్ ఎర్త్ దగ్గర జీ వాల్యూ ఎంత? 8th క్లాస్లో గ్రావిటేషన్ చాప్టర్లో ఉంది. కెప్లర్ లాస్ అవన్నీ చదివారు కదా గ్రావిటేషన్లో. ఇన్ దట్ సెంటర్ ఆఫ్ అర్త్ దగ్గర జీ వాల్యూ ఎంత? 0. యాక్సలేషన్ డ్యూ టు గ్రావిటీ వాల్యూ ఎంత? 0. సో if you are substituting 0 here, what happens to this time? T is equal to 2 pi under root of L by 0 ఎంత?
0.
Anything by 0.
Infinite.
Not defined. Infinity. Anything by 0 ఎంత? Infinity. అంటే సింపుల్ పెండులంని మనం సెంటర్ ఆఫ్ అర్త్ దగ్గరికి తీసుకెళ్తే ద టైమ్ పీరియడ్ విల్ బికమ్ హౌ మచ్? ఇన్ఫినిటీ. ఇన్ఫినిటీ అంటే అర్థం ఏంటి? అదొకసారి ఇటు నుంచి సింపుల్ పెండులం లెఫ్ట్ సైడ్ నుంచి రైట్ సైడ్కి వెళ్ళింది అనుకోండి, మళ్ళీ మనం లెఫ్ట్ సైడ్కి వస్తేనే 1 అని కౌంట్ చేయాలి కదా. సో ఒకసారి రైట్ సైడ్కి వెళ్తుంది కానీ మళ్ళీ లెఫ్ట్ సైడ్కి రాదు. ఇంకా మనం సంవత్సరాలు ఎదురు చూసినా మళ్ళీ రాదు. అది వస్తేనే మనం కౌంట్ చేయొచ్చు 1 ఆసిలేషన్ అని. దట్స్ వై టైమ్ పీరియడ్ బికమ్స్ హౌ మచ్? ఇన్ఫినిటీ. ఓకే, ఇది కూడా రీజనింగ్ క్వశ్చన్ చాలాసార్లు అడిగారు. వాట్ ఈస్ ద టైమ్ పీరియడ్ ఆఫ్ సింపుల్ పెండులం ఎట్ సెంటర్ ఆఫ్ అర్త్? సో టైమ్ పీరియడ్ బికమ్స్ హౌ మచ్? ఇన్ఫినిటీ.